Flipped classroom video for Maths AS Unit 1, Classifying Stationary Points. From our previous work, we know that there are three types of stationary points. We have a maximum point, we have a minimum point, and we have a stationary point of inflection. And for all these, the curve has a gradient of 0 at the stationary point. So let's have a look at the different types in detail. If we look at a maximum point and blow up the graph so we can see it more closely, we can see that the gradient to the left of the point is positive, so that's this dotted line here. And the gradient to the right of the point, this dotted line here, is negative. So we have that to the left of this point, or below this point, in the x direction we have a positive gradient, at the point we have a 0 gradient, and to the right or above the point we have a negative gradient. So the gradient is decreasing. Let's have a look at a minimum point. Well, this time we can see that the gradient to the left of the point, so this point here, is negative. The gradient to the right of the point is positive. So we have to the left of the point or below the point, the gradient is negative. At the stationary point the gradient is 0, and above the stationary point the gradient is positive. So we can see that the gradient of the graph or of the function is increasing. Okay, for a stationary point of inflection, we can see that the gradient to the left of the point, so say this point here, is positive, and the gradient to the right of the point is also positive. So we have this situation. Below the point the gradient is positive, at the point the gradient is 0, and above the point the gradient is also positive. Now we also need to bear in mind that this could be the other way round for a stationary point of inflection. We could have negative, then 0, then negative. But we'll stick with this one for now. So, gradient decreasing to the left of the point, it's 0 at the point and increasing to the right of the point. Let's have a look at these all together. These are the little tables that we've seen previously. Now if we were to draw a graph of the gradient, then for the maximum it would look like this. It's positive, then 0, then negative. For the minimum, it's negative, then 0, then positive, and for the stationary point of inflection, it's positive, then 0, and then positive again. So let's summarize. We have the gradient at the stationary point is 0, which we can see now with those little blobs. The behavior of the gradient for the maximum is decreasing, and it's going from positive to 0 to negative. For the minimum, the gradient is increasing, going from negative to 0 to positive. For the stationary point of inflection, it is decreasing to 0 and then increasing. So it's positive 0, positive, and remember this could be vice versa. if the stationary point of inflection were the other way up. If we look now at the gradient of the gradient, so this is the second derivative, or d2y by dx squared, then for the maximum it is decreasing, so it's a negative gradient of the gradient, or d2y by dx squared is less than 0. For the minimum, the gradient of the gradient is positive, the gradient is increasing, and so d2y by dx squared is greater than 0. For a stationary point of inflection, because the graph of the gradient comes down to the left of the point, then its gradient is negative. At the point its gradient is 0, and to the right of the point the gradient of the gradient is positive. So that means for the second derivative, or the gradient of the gradient, we had negative, then 0, then positive. Therefore, we see that d2y by dx squared changes sign. So for the stationary point, you need to establish that the second derivative is 0 at the point, but also that it changes sign, either from positive through 0 to negative, or vice versa.